Hey everyone, we are Acrovan Adventures, and in today's video we are going to show you how to wire an AC electrical outlet with stranded wire. Before we start, I do want to mention that we are not trained electricians, we are not professionals, we are just giving you insight as to what we did for our wiring, but it's always recommended that you consult or hire a professional for your own electrical system. Before we start wiring, I do want to confirm that our battery is disconnected. There is no power source coming through these wires, so they are safe to work with right now. Another important thing to note, if you do want to be using traditional alternating current or AC outlets in your van, you need to have an inverter because most builds like a van or a bus are using a DC battery, and you need to convert that DC energy into alternating current in order to use something like this. In order to do that, we use what's called an inverter. We're not going to talk about that here, but if you are interested in learning more, you can check out our other build video where we walk through our entire electrical system, and that's linked up here. But if you do have an inverter and you are trying to use alternating current outlets like the one here in your own build, you can keep watching. We're going to show you how we do that in this video. So what I'm about to do is wire the first of a couple AC electrical outlets, 120 volt. In a bus or a van, there's a couple of really important things. One is that you need to use stranded wire. That is different than a house. The typical house will use Romex, it's solid copper wire. According to most regulations, you need to have stranded wire in a moving vehicle because the Romex, the solid copper, can become brittle as you drive and as you bounce around. So that could break, that could be a safety issue, you don't want to do that. So we have this Ancor marine grade triplex wire. And there's 3 on the inside of this sheath. There's a white, a green, and a black. The black is the hot, the white is the neutral, and the green is the ground. Your outlets will have a clear label on the back of which one is which, and there's usually a green nut that shows you which one is the green ground. A couple other considerations. It's really good to have a GFCI outlet. That's the kind with the little reset button. They're safer for like anytime your outlet might be near water or potentially a lot of humidity, that kind of thing. So it's important that at least your first one in the circuit is GFCI. What I mean by that is for each AC breaker, you can have more than one outlet in the same chain of wires. So you can basically link the first one to the second to the third and keep going as long as you don't exceed the amperage for your whole circuit. But the first one, so the closest one to your breaker, to your power source, should be the GFCI. All the extra ones can be anything after that. But as long as the first one is GFCI, the rest will be protected in the same kind of GFCI circuit, which is great. You might be asking why you care. The GFCI ones are probably about $20 and the other ones are probably about $5, so you can save some money that way. One really weird thing and what we're going to talk about here is the fact that these are mostly designed for solid wire. Basically, when you're going to start wiring it, you can unscrew this screw. There's like a little thing, and it's definitely designed for a solid copper wire. You kind of create a little hook and then you can easily manipulate it into there. If you try to do that with this by cutting the whole end off, it's going to get frayed. It's going to just kind of go everywhere. That's not very good. So I found very few videos of how to wire with stranded wire. We're going to show you what we do today. So first things first, I need to get to each of the wires. I take a fairly dull knife, and then I can peel this outer layer back a bit. I like to just cut this off so that it's out of the way. Awesome. Okay, so now you see I have a white, a green, a black. The black is the hot, the green is the ground, and the white is the neutral. So what are we going to do that's different? So I got this PVC box, reason being the cover, like a standard outlet cover, fits nicely over this, and I didn't want there to be any gaps or anything like that. And because I can surface mount this, so you'll see these 2 little things. That means I can just stick it right to a wall and then screw into it like that. I haven't quite decided if it's going to go here or here, so I'm leaving it for now. The only other mod is you can see I got this little 3/4 inch wire. I don't know what it's called, but it basically squishes the wire down so that you can make sure it doesn't bounce out. All you have to do is press this into here, and it's pretty secure. It doesn't move now, so we should be good there. So you're going to take your wires, you're going to feed it through the clamp. I might even just clamp it down now. You might not want to do this at first because you might want to trim some of your wire. I'm going to be able to trim it from the other end because I did not actually install it yet. So now you can see my wire is really tight in here. I can't pull it out. That's great because if the bus is jiggling, this will still be loose on top of the outlet, which is awesome. I like to leave a little bit of wiggle room, but I don't want to do too much because then it'll be kind of hard to work with. So I'm going to trim these a bit. Instead of trimming back the wire from the very end, we are going to do it in the middle, and we're actually going to leave some hanging off, which is what we want. So we're going to start with the green, the ground. It's going to be like down like this. You find the green thing. It's pretty clearly labeled on the back of the outlet itself, but I'm just going to loosen it up. And these screws don't actually come out, so you have to just kind of make it work. So we're going to take our strippers, and instead of putting it all the way at the end of the wire, we're going to do it in the middle. So I'm going to put it down here. I'm going to strip a bit in the middle like that. You need like 1.5 inches maybe of wire showing. Awesome. So now I have this. I am going to twist it so that it's actually really tight. That makes it like quite a bit more sturdy. Again, I found that if you twist them counterclockwise, when you screw the screw down, it actually kind of makes it tighter. If you twist it clockwise, the screw will fray them out and it will open up. And then what I'm going to do is I am just going to loop this around my screw. The most important thing I want to reiterate is that if you twist the wires counterclockwise and then you attach it, it prevents the wires from fanning out during the installation. So when you're doing this, twist the wires counterclockwise, make it nice and tight, and then attach it to your outlet. We also should mention that you might see us flipping between this GFCI outlet and a traditional outlet. We actually kind of combine video clips from different parts of the bus, but we do have a GFCI outlet as the first outlet in both of the circuits in our bus. You can continue to wire additional outlets in series. There are lots of other build videos out there online that would help you know how to do that. But the important thing here is that we're using stranded wire instead of normal copper. Everything else still works the same exact way. We are Acrovan Adventures. If you're interested in seeing the rest of our build, how we did anything else, be sure to check out our build series, and a few of those videos will be linked in the description below. We will also include links to all the tools that we used in this video. We're Acrovan Adventures. Thanks for watching, and we'll see you next time.